All right, here's 2.3 part 2. We're going to be actually finding the focus and the directrix of some equations here. Starting off, what is the focus? The focus, again, is this red dot inside the parabola. The definition says it is in the interior of the parabola and lies on the axis of symmetry. Okay, so it's always straight up or straight over from the vertex, depending on what type of parabola we are working with. The directrix is this line down here, this line right down here. Okay, that is also equidistant from the vertex as the focus is. Okay, so this lies halfway, nope, sorry. It is perpendicular to the axis of symmetry. All right, some big notes here, some big notes. This distance from the parabola, or from the focus to the vertex, right here, is 2, or sorry, not 2. Let me start over. The distance from the focus to the vertex, so this distance here, is P. Okay, this distance from the vertex straight down right here is also P, and we solved that in our first exploration. That is P. So that's the distance. Just a side note, not extremely important right now, but if you went right, so if we made a right angle right here between the focus and our parabola, this is 2p. Okay, same with this side, 2p. So when we start graphing, we make it a lot easier just to find 2 points on the graph. Okay, so P, that is our main focus, P. We want to focus here. I want you to think of this equation. Okay, y equals x squared. We like that equation. That is our parent function for the quadratic formula, right? Vertex is at 0, 0. Okay? But we have to use this equation, y equals 1 over 4p. That's going to be huge today, 1 over 4p. It's going to be extremely important in this lesson. Okay, that's how we're going to find our focus. Take a look at this next equation. Okay, this one is a little different. We haven't talked about this one much, if at all. X equals y squared. I showed you what that looked like in the first part of the video. Okay, but x equals y squared. That is a sideways parabola. That's this parabola here. Okay. We are still going to be using 1 over 4p to solve for the focus. Okay, the vertex on this equation, x equals y squared, it doesn't move, right? Our vertex is still at 0, 0. And we'll get into this. We'll get into this here in a second. Down below with some extra practice. Okay, nothing really changes here other than we have some shift in our vertex, right? And we just went over that 2.1 and 2.2, where this would move it right and this would move it up, right, our vertex. And then we're still looking at 1 over 4p for our focus. The only thing that really changes is our focus now. We find P, but then our focus is H and then K plus P. So it's still over to the right, but then we have to move it up even further from our vertex with that plus P. Again, we'll go over some examples here in a second. Down below, when it's y squared, notice what changes. Still do 1 over 4p, but now we have h plus p. Okay, so now we're even going further to the right or left, which makes sense because our parabola opens to the right or left. If you're confused, it's okay. We're going to get through it together. This one here says, use the distance formula to write an equation of the parabola. And they give us the focus and the directrix. Let's start with a picture. Pictures always help. Our focus is at 0, -8. So go down 8. Here's our focus. It's at 0, -8. Our directrix is at y equals 8. So we're going to go up to 8 on our y. And there's our directrix. Y equals 8. And this goes back to that first video, that first exploration in GeoGebra. My vertex is right between those two, so right at 0, 0. There's my vertex, right? 0, 0. And it opens up downwards because my focus is down. Okay, so we want to use the distance formula to create an equation. Here's what they want us to do. We know, I know my drawing is a little off. Maybe I'll do a little better job here. My parabola is going to go way out here. Okay. But we know that the distance between our focus and our parabola is the same distance to our line. Okay, let's find this distance here. What are we going to call that point? Well, we really don't have a point to call it other than x, y. Okay, we really only have one number to call this point, and that's 8. We know that it's going to be a x, or something x, and then 8. And we know that those two lines equal each other, the black and red line. Okay, so the distance of the black line would be x minus 8 squared plus, oh, sorry, not minus 8, x minus 0, because our point for our focus is at 0, x minus 0 squared plus y minus a -8 squared. Okay, this is going back to the distance formula. That is going to equal our red line, where we have x minus x squared plus y minus 8 squared. Okay, now we're just going to simplify. X minus 0, that's just x. We're going to have x squared plus y plus 8 squared. That's going to equal, simplify the red, x minus x is 0, and 0 squared is 0. So we're going to have just y minus 8 squared. So I simplified. At the distance of both lines. I'm using the distance formula for both lines. Simplify even further. I'm going to square both sides just so we can get rid of those nasty square roots. So I have x squared plus y plus 8 squared still equal to y minus 8 squared. Now, I'm going to simplify further. I have x squared, but then I have y plus 8 times y plus 8 is equal to y minus 8 times y minus 8. So I still have x squared, plus if I multiply these two binomials together, I get y squared plus 8y plus 8y plus 16, or not 16, 64. Is equal to y squared minus 8y minus 8y plus 64. Okay, so I'm going to erase this stuff up here because I'm running out of room. And I'm going to simplify that up top here. I have x squared plus y squared plus 16y plus 64 is equal to y squared minus 16y plus 64. Okay, now I'm going to simplify. If I subtract y squared, that cancels out. If I subtract y squared, that cancels out. If I add 16y, that cancels out. Add 16y, I get 32y. If I subtract 64, that cancels out. If I subtract 64, that cancels out. So I have nothing on the right side, and I still have x squared plus 32y equals 0. If I scroll up here through all this mess, if I scroll up, look at this equation. Right up here, this equation here. Y equals 1/4 p x squared. I want y equals x squared. So if I subtract the 32, I get x squared equals negative 32y, and divide by 32, I get, actually, you know what, leave it as that. X squared equals negative 32y. I'm going to check my work here. What are my answers? Right here, x squared equals negative 32y. Did it. Perfect. Done. I don't like working with fractions, so I don't want to divide negative 32. I'm just going to have x squared equals negative 32y. Okay, that was a mess. That's a lot of work. Alright? I want you guys to try this one. This one might be a little easier. So if I have my vertex is at 0, 0, my focus is at 0, 1. I know that my directrix is going to be at 0, negative 1. If I draw my parabola, I know that this is 0, 1. I know that this is y equals negative 1. Can I find this distance? That's going to be at xy. And this distance at x negative 1. Okay, actually let's just go through it since I've already drawn all this stuff. Oop, too big. I need two different distance formulas here. I have the square root of x minus 0 squared plus y minus 1 squared. okay, that was from my focus to my line, or to my parabola, is equal to, we have the square root of x minus x squared plus y minus negative 1 squared, or y plus 1 squared. Clean that up. We get the square root of x squared plus y minus 1 squared is equal to x minus x at 0, so we have y plus 1 squared. Okay. If I square both sides, I just get rid of the square root. So I have x squared plus y minus 1 times y minus 1 is equal to y plus 1 times y plus 1. Simplify. X squared plus y squared minus y plus 1 equals y squared plus y plus y plus 1. And again, all I did was FOIL that out. I'm going to erase up here so I have some room. Simplify, I have x squared plus y squared minus 2y plus 1 equals y squared plus 2y plus 1. What can I cancel out? Do it in blue. Plus 1, those cancel out. Minus 2y plus 2y, those cancel out. Y squared, those cancel out. So x squared equals 0. Oh, I'm sorry. Something doesn't cancel out. That doesn't make sense. We have minus 2y and plus 2y. Minus 2y plus 2y. If I add 2y to both sides, that cancels out, but this becomes 4y. So x squared equals 4y. Done. Again, check my work. X squared equals 4y. Perfect. All right. Down below here, we have our equation. And we want to find, actually, focus on where is this parabola opening up. I want you to think of just this equation. Y equals x squared, because we have x squared. Okay. Now, let's scroll up. Let's look at, oh, going too far. Let's look at our equation we should be focusing on. Right here. Y equals 1 over 4p x squared. That's the form we want to get this equation into. Y equals 1 over 4p x squared. Okay, so how do I get y equals something? I'm going to multiply, or I'm actually going to divide negative 2 from both sides. So I get negative 1 over 2 x squared equals y. Backtrack just a little bit. This graph right here, where's my vertex? It's at 0, 0, right? And nothing changes with my vertex in this equation. Now, I'm going to take negative 1/2, and I'm going to set that equal to p, or 1 over 4p. And I want to solve for p. I'm going to multiply by negative 2 on both sides. So I get 1 equals negative 2 over 4p. I'm going to multiply by 4p on both sides. 4p equals negative 2. And I'm going to divide by 4. P equals negative 1/2. So my distance from my vertex to my focus is negative 1/2. So I'm going to go to my vertex. I'm going to go down negative 0.5, which is about right there. And that's my focus. My directrix is 0.5 above there, right here. Now, my parabola. To get 2 points, remember when I said if I just go over 2p from my focus, so my negative 1/2, what's 2 times 1/2? It's 1. So my vertex just 1 over, 1 over. There's my parabola. Okay, so we just want it in y equals x squared or x equals y squared form. This one here, I'm going to add that 5x over, so I have 1/3 y squared equals 5x. Now I'm going to solve for y, or I'm going to solve for x. I'm going to divide by 5 on both sides, so I get 1 over 15 y squared equals x. My vertex is going to be at 0, 0, but I'm going to be opening up sideways because I have y squared. I have y squared. Okay, so my parabola is either going to be like this or like this. Okay, I need to find my focus. My focus, I'm going to take 1 over 4p equals 1 over 15. I'm going to solve for p. I'm going to multiply by 4p on both sides, so I get 1 equals 4p over 15. Multiply by 15 on both sides, I get 15 equals 4p. And I'm going to divide by 4. p equals 15 over 4. So, from my focus, or from my vertex, I'm going to go to the right 15 over 4. That is 3.375, so that's going to be about right here. My directrix is going to be on the other side. And it's going to be this line right down here. If I take 3.375 and multiply by 2, sorry, 3.75 times 2, I get 7.5. So my other point is going to be at 7.5, right here, right along that, right there. Okay. I'm going to stop this video. This will be part 2. We still have part 3 coming.